Okay, so we are still on section 7.3, Cramer's rule, okay? And today we're going to talk about systems of linear equations 3 by 3, okay? And I guess you know that what happens in a 3 by 3 system is that we add a third variable, okay? Now we have x, y, and also we have z, okay, equals 3. So I'm going to write the three equations on three variables. So this is 2x plus 3y equals 5, and this is x plus y minus 2c equals 0. Okay, so that's my system of linear equations 3 by 3. As I said, three um, three equations on three variables. Okay, so what happens here? You see, I have no c in this case. Okay, that means that the coefficient is c. No, nothing more difficult than that. Okay, so as you know, uh, from 2 by 2 systems, the way we used to solve this was first we found this determinant d, and then we divided some other determinant by d, whatever. So we're going to define that now like this. X equals what we call d sub x divided by d. What's that? D is the original determinant, the one which is made out of this coefficient, and d sub x is the one where I replace the first column, okay? So this quotient is going to give me the value of x. I will also have y, which is d sub y divided by d. D sub y is the determinant replacing the column in the middle, which is the one that corresponds to the coefficients of y. And then c will be d sub c divided by d. And once again, d sub c is the determinant, but replacing the third column, which is the one that corresponds to the coefficients of c. Okay, so then let's start by computing the value of the determinant d. As you know, this is composed by these 9 coefficients. So 1, 2, 1, 1, 3, 1, and 1, 0, minus 2. Okay, and first thing we need to do here is we copy the first two columns, 1, 2, 1, 1, 3, 1, and then we start computing. As you know, diagonal, 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 and then the secondary ones, diagonal, diagonal, and diagonal. Okay, so then 1 times 3 times 2 is, sorry, 1 times 3 times minus 2 is minus 6. 1 times 0 times 1 is 0. 1 times 2 times 1 is 2. Minus 1 times 3 times 1, which is 3. 1, 0, 1, which is 0. 1, 2 minus 2, which is minus 4. Okay, and this gives me minus 4 minus minus 1. Okay, and this is minus 3. Okay, so my determinant d equals minus 3. Okay, so let's start by computing d sub x. D sub x is the same coefficient, there's the same determinant, but replacing the first column. And that means that we put the independent terms on that column. So this is how it's going to look like. Okay, so let's copy the first two columns again, 3, 5, 0, 1, 3, 1, and let's start computing. 3 times 3 times minus 2, that's minus 18. 1 times 0 times 0 is 0. 1 times 5 times 1 is 5. And then the secondary diagrams. 1, 3, 0, 0, 3, 0, 1, 0. 1, 5 minus 2 is minus 10. Okay, and this gives me minus 13 minus 10. So minus 13 plus 10 is minus 3. Okay, so if this sub x equals minus 3, let me move the camera a little bit, like that. Okay, so if this sub x is minus 3, it means that x equals minus 3, which is this number, divided by minus 3 again, which comes from this calculation. So it means that the value of x for this system is 1. Okay, we need to repeat the process for y and for c. So let's erase this. Let's change the first two columns. Let's change the sub-index. And this is going to be now this sub y. In this sub y, the first column is the same as here, but it's the second column which is replaced. Okay, so once again, let's copy the first two columns and let's start computing. 1, 5 minus 2 is minus 10. This column is diagonal 0, and this diagonal is 0. Then the secondary diagonals 1, 5, 1, 5. This diagonal is 0. 3, 2, minus 2, that's minus 12. And this is minus 10 minus 7, which is minus 10 plus 7, minus 3. Minus 3 again. Okay, so once again, y equals this of y, which is this number, minus 3, divided by d, which is this number, which is also minus 3, and it gives me 1. Of course, this is not going to be all the times like this. I can have systems with any possible solution. Okay, but this one is an easy one, and it's easy to solve. But it doesn't have to be the case, as you already know. So let's finish this by computing the sub c. The sub c is the determinant where the column that changes is the third one. Because, as I said before, that's the column that corresponds to the coefficients of c. Let's copy the first two columns and let's start computing. 1, 3, 0 is 0. 1, 5, 1 is 5. 3, 2, 1, that's 6. And now let's subtract the secondary diagonals. 3, 3, 1 is 9. 1, 5, 1, 5. 1, 2, 0, 0. So this is 11 minus 14. So 11 minus 14, once again, is minus 3. Okay. And this means that this system has 1, 1, 1 as a solution. Okay. So these are the values for the three variables, and we can also say that the solution is 1, 1, 1. Okay. In this case, as you might have guessed, maybe this is also a point, but this is not a point in a coordinate plane, in a two-dimensional plane. Now it's a point in a three-dimensional space. Okay, we are not going to graph that in ninth grade, but just for you to know that. Okay, I'm going to stop the recording now.